Welcome to the Civil 3D InfraWorks Civil 3D interoperability story. Now we are in AutoCAD Civil 3D, where it is easy to collect different types of data for our land site that we want to redevelop and make detailed design of infrastructure and land uses. Here, for instance, we have this georeferenced aerial photo and two feature classes for green areas and buildings. We will also import a point file to create a model of land surface. Thus it is ready. In a 3D view we can see a small feature in the northwest part of this area. Of course, before creating a precise design and project documentation, we need to develop some kind of general idea how this area should look after the project has been completed. For that we have Autodesk InfraWorks, a very efficient and at the same time quite simple software product. This is why we will export this Civil 3D file to the IMAX format. This is an exchange format for InfraWorks. And now we are Autodesk InfraWorks. First we will import the IMAX file we've just created with AutoCAD Civil 3D to get the land surface. We will see that InfraWorks quite correctly rebuilds surfaces. Then we'll add the aerial photo. To place it correctly, we need only to assign a coordinate system in which it was referenced. It is automatically draped over the surface. We'll import the feature class for buildings. For its configuration, we need to correctly select the data type. We will select the corresponding attribute from the source data table to define the slopes of roofs. And finally we'll decide to drape the features over the surface. As we see, some of them are outside it. We'll simply select and delete them. We want the buildings to look more realistically. For that we'll select all of them and apply some facade style for them. We can define any arbitrary selection of features to change their properties and parameters, for instance heights. Now we'll take an individual building and redefine its facade style and assign some roof material to it. We'll also regulate its height. Then we'll add the green areas. We'll configure this feature class in a similar way. For the style, we'll apply some kind of trees for all the features in this feature class. And now we'll set the spacing between the trees, the variance of this spacing, and apply scale factors for sizes of the trees. Thus we have collected all the data we have at this point for our land site. And it's time to make something new. For instance, we'll sketch a new road to make this area better accessible. InfraWorks builds roads just with slopes to the ground surface. Our road is on too high elevations relative to the surrounding area. We'll simply solve this problem by adding a point to the profile and placing this point lower. We'll import a model of building from Autodesk Revit. Probably it was constructed in some other units, for instance in feet. This is why it is too large. We'll simply solve this problem thanks to scale factors. For instance 0.3. Remember that all the model of this land site is in meters. We'll slightly move the building and rotate it. We'll draw a land parcel for this building. To get rid of fillets at the corners, we'll simply add more vertices. Suppose we want to cover our parcel, but the current style doesn't support this. We'll simply copy it and then we'll edit this copy. This is in fact a new style. We'll remove the outline from it and on the contrary we'll add a fill to it. And finally we'll apply this new style to the parcel. Next we'll sketch a road across the parcel and connect it to the main road. InfraWorks automatically creates intersections of roads. Then we'll add a small water body in front of the building. We will fix the most of the parcel boundary with a stone fence. But here we'll put a metallic semi-transparent fence. We'll put trees along the fence. And set the spacing, the variance of this spacing, and apply scale factors to sizes of the trees. And now we'll export everything we've done with InfraWorks back to the IMAX format to get it with AutoCAD Civil 3D. We can easily create animations of different types with Autodesk InfraWorks. Now we'll create a camera path animation. but that will take from 10 to 15 keyframes. Animations created with Autodesk InfraWorks can be converted to common video formats. You can see video output from this animation on my channel. Its name is an example of Autodesk InfraWorks animation output. So the animation is ready, and we'll start to convert it to an AVI format. We are back to AutoCAD Civil 3D, and first we'll import the MX file we've just created with Autodesk InfraWorks. We'll delete all unneeded objects. The most important is that we have successfully got the center line alignments of the roads created with Autodesk InfraWorks. Furthermore, these alignments are with profiles. We'll create intersections of the main road and the road across the land parcel. In these dialogues we can specify parameters of intersections, for instance width of the roads participating in these intersections. AutoCAD Civil 3D creates exact lines where the slopes from the road meet the ground surface. In the same way we'll create the second intersection. So this is a part of model of our road that can be a good and sufficient base to develop the project. That is, to get elevations, contour lines, volumes, section views, profile views. We'll stretch this model all over the center line alignment of the main road. In a 3D view we can clearly see the fills and the cuts. Thus, thank you for watching this video, and you are welcome to comment it and ask me if you want to know more, and if something isn't clear